Hi, audio friends. My name's Jonathan Smith. I'm an audio engineer specializing primarily in systems engineering. I do a whole lot of flying and tuning PA systems. Today we're going to be working on Venue Synthesis. It is JBL's software for designing venues and for designing arrays to go into venues. Let's get started on a new project. So we'll open a new project and we're going to immediately, we're just going to look and see if we can import either 3D geometry or a PDF. For this upcoming show, I know that I have a DWG available. So we'll go ahead and import this DWG, see where that gets us. I do like to tag by layer name. That helps me see and exclude objects out of the drawing. Let's see how many layers we have going on in here. That's not too many. This might actually be a fairly clean drawing. We can look at, on the left side of the screen, basically a solo button for the drawing, where we can pop open very specific things that we want to look at, find out what exactly is labeled what. Doesn't seem like we have too many items that are completely extraneous to what we're doing. The first thing we need to do is move this DWG to our origin point. This is a challenge here in America because we work in feet and this grid is set out in 10-meter squares. So here we have to estimate how many squares we have to shift it. Horizontally on this X, we need to shift 1, 2, 3, 4, 5, 6, 7, 8.5-ish grid squares. Vertically, we need to shift 1, 2, 3, 4, 5.25. We can do some math on that. Transform. We're going to move. Let's start with about 270 feet in the negative direction. And about 165 feet, again in the negative direction. Let's see where that lands us. That is a lot closer. We're going to say that this right here is going to be the center of the arena, so we still have to shift quite a bit. Transform X, we're going to move another 3 feet. Y, we'll move 3 feet. See where that gets us. Again, in this instance, we have to move negative. Let's shift X. Another 3 feet. Y will move half a foot. Too far. Move it back 1 foot. And that is pretty darn close to center of the arena. After that, we can start making some planes. The only planes that I make as a rectangle, the only planes that I make as a straight rectangle is going to be the stage and the floor. Everything else I create as a special object. Let's go ahead and create our floor. Center that up. Maybe we'll make that a little bit wider. Need to create a tag for this. Create a tag. What is the floor? This is a audience seated plane. After that, we're going to go ahead and hide that so that we can create another plane for our stage. Let's hide the grid. We can see our stage a little better. One more rectangle for our stage. Make this architectural. Again, creating a tag. Stage. Our stage is 56 by 40. Center that up in the room. Now we have a floor and a stage in place. After I make my stage and my floor, I find that the easiest planes to make next are going to be the sides. So from here, I'm just going to make some flat planes. Maybe I'll make some estimates on what the heights are, but for the most part, I'm just going to make some flat planes that correspond with these distances. We can pull out our tape measure tool from our center line. We're going to be 41 feet, 42 feet to the front, and 131 feet to the back. 41 feet, 131 feet. Let's make straight plane. Depth, height, 41 feet. We'll guesstimate a height of 2 feet. 131. Again, we're just putting a number in for right now. This might be 25 feet tall. With this arena, I guarantee it's going to be taller than that. But that is roughly what we are going to look at. Adjust our width based on our drawing. Looks to be about double what we have there, so let's check 135. 135 is almost right. We'll bump that up to 140, just so we can have some overlap on that plane. I have found that the top view, which I usually work in, does not give well-defined edges. If we rotate, we can see that the edge of this plane is actually just above the edge of the drawing, but from our top view, doesn't necessarily look that way. We're going to rename this. Naming conventions are super important so we don't get confused later. This is going to be bowl stage left. We can, if we want, we can mirror that across this plane, make that a bowl stage right. Most of the time before I go into a venue, I don't do all of the mirroring. Reason being is when I get into the venue, I'm actually going to do a bunch of measuring, and I'm going to modify this plane utilizing our distance and angle function. So I'm going to modify it on show site. And once I do that, then I will mirror over to the other side. It just reduces the number of clicks and the amount of information that I have to put in and the amount of information I change if I'm only modeling half of the arena at once. So when I'm doing my pre-production work, I will typically just model one half of the arena. Later when I get on show site, I can actually measure what this plane is and do a mirror image on the other side. That allows me to reduce the actual workload that I'm doing right now and save me a little time later when I only have to modify one plane instead of two planes. So we have this plane in place. We hid our bowl stage right. Let's go ahead and work on our end of the arena. When I'm building a curve section, I like to measure from the origin to the front of the curve using our tape measure. In here, it looks like we are missing some of the seating, but we're going to call this portion of the curve, front of the curve is going to be 100 feet, and the rear of our curve is going to be 189.5. So depth is going to be 100 feet, height of 1. We said 189.5. We're going to fake a number in here just so that we can see some of it. Now this has appeared up here. So we need to rotate 90 degrees. And up there. I think this might be the most confusing part of how to get these curves to work, is the front width and rear width. All right, so getting these curves to work well, I think is one of the most confusing tasks to accomplish here. Using the front width and the rear width, we're going to measure and apply those. The measurement here, this will be the front width from here to here, and the rear width is from here all the way to here. So we can kind of cheat and use measurements that we already have in here in order to get the front and rear width on our curve. I like to use our side measurements. Right now we have a depth of 41 to here and 131 to here. So our curved measurement should be pretty close to 82 and 262, just based off of doubling that measurement. 82, 262. Front width, 82. Rear width, 262. That is pretty close. Since this is a significant curve, we're going to up the number of segments that we have to get closer to a semicircle. Again, remember I said that even though the drawing might not line up perfectly from the top view, if we rotate, we can see that immediately that pops to be pretty darn close to the edge of our drawing. Now, once we get into the venue, we can double check the heights of these, double check the lengths, double check the depths, and we'll use our distance and angle for that in order to get a very accurate measurement. I have a laser disto that also offers an inclinometer on it, and that allows me to get really accurate measurements in the venue. So that's most of the venue modeling that I will do here before I get on show site. After this, to speed things up, I'll go ahead and I know what our rig is going to be. We're going to put in A series. I have A12s, 16 per side on the main hang. the layout of these. This is different than the special objects. We need to rotate this a negative 90 degrees instead of a positive 90 degrees. We're going to position in the room right at the front edge of the deck. They're 64 feet wide on the arrays, and we try and have the top of the array at 44 feet on this tour. That allows us to have good clearance for the audience to see the video walls and the lighting, and that does pretty well for us. Let's go ahead and add another array in there for my wings. I'm going to do 12. Again, we are going to rotate a negative 90 degrees. Spacing is going to be at about 72. And let's look at our position. Minus 50, we'll give that. Then our group parameters, we want to aim these out. Again, this is a negative 60, not a positive 60. And our layout, since this is 12 boxes, I try and get the bottom of the arrays at the same height instead of the top of the arrays. We're going to end up at about 38 feet for height. Once we curve these, they should be pretty close to level on the bottom, but we will have to double check that once we get on show site. So anything that I can get done ahead of time just saves me a little bit of time in the morning in the venue, allows me to be a little more efficient with my time, and lets me sleep in about 2 more minutes because I've already added these into the venue. We'll catch up again tomorrow, and we'll go through my workflow in the venue in the morning. We'll show you some measurements, show you how I modify the planes, and we'll do the prediction tomorrow morning.